Hey guys, yeah, so perhaps save the best for last, because in this integral we can't readily choose a u. We have to do a little something before we even start. And so this is a cool, funny example. Remember the exponent rules, which said that a to the b plus c is equal to a to the b times a to the c. So we're gonna apply that exponent rule here in this part. And when we do, we can rewrite our integral as the following. Integral of 4x times e to the x squared. And here's where the exponent rule is going to be applied. So e to the x squared times e to the x squared. And then dx. Yeah? Cool. Now, not only does this look cool, but it's also a lot, so we're unsure of how to pick u from it. But if we look at the composition of functions, yes, this and this are both compositions, but the bigger composition, this guy, then we can try and view it through the lens of f of g of x. Technically, it could be thought of as a composition of two or more functions, but let's keep it simple and just see it as a composition of two functions, f of g of x. So then clearly f will have to be e to the x, and then g will have to be, or g of x, or g, will have to be e to the x squared. And we'd said that in this kind of a composition viewing lens that we make u g of x. So that'd mean that here we pick u to be e to the x squared. Well then the question that begs is du the derivative inside of what remains of our integral? Let's see. If this is u, then du would have to be e to the x squared, and by chain rule, oh, sorry, I went too far. Du would have to be e to the x squared, and by chain rule, times 2x, and then dx, right? So this is du, well, the right-hand side of the equal sign, right here. So what we're asking is this guy inside of the rest of our integral here? Well, if we look here, it's almost there. It's 2 times what we want that we find inside of our integral. So what we want is exactly this, but we have 2 times that in here. But we're not bothered by constants. I've said that in the previous solutions. So we don't care that this is a 4 instead of a 2. Constants are easy to deal with. So we think that we've done well picking u to be e to the x squared, and we're going to move forward. We don't think, we know. Yeah? Okay, so let's move forward. So what we have then is going to be 4x times e to the x squared. And by the way, for ease of seeing what I'm going to do, instead of 4, I'm going to write 2 and then times 2x e to the x squared. Nothing wrong. This equals that, right? Okay, so good. And then times we have e to the x squared is our u. Where did I write it? Up here. So e to the u. And then dx, which we haven't solved for, we're going to solve for using this statement. So using this statement, as usual, we're going to isolate dx and write that it's equal to du divided by 2x e to the x squared. Okay, cool. So instead of dx, we can write du divided by 2x e to the x squared. How wonderful, because we're going to do this now. Boom, boom. Yeah, so our integral is going to simply reduce to the integral of 2 e to the u du, and we could take out the 2 and write that what we have is the integral of just e to the u du, and that's pretty simple. This is 2 e to the u plus c. But what was u? U was e to the x squared. So that's all that we have left to do. Replace this u with e to the x squared. So our solution is 2 e to the x squared plus c. Yeah? Cool. I hope you enjoyed this. Take care. Sorry.